I'm going to try to help you guys get your aluminum foil lab written up well. First of all, make sure you put the purpose down is to calculate the thickness of aluminum foil. Of course, you have your materials, list those. The procedure, I expect you to be careful here and not use any personal pronouns. I did have a few lab reports that had too many of those in them, so let's tighten those up. Data and results is really what I'm going to try to take care of today and help you make some calculations on an imagined piece of foil. And then finally, your conclusion will say pretty specifically, like the thickness of aluminum foil found in this experiment was, and you'll give a value. So let's spend our time on this data and results. Really, we had two measurements. If you thought of our piece of foil, so here's the picture. If you thought of the foil as like a block, we were able to take and get a measurement with our ruler on these two edges, no problem. The problem really came in when we would try to maybe get this very, very thin edge that was the thickness of the foil. And I think that's, we're going to call that Z, if you will. So I'm going to pretend I can zoom in, and this thickness was Z. Now I know that volume equals the X times the Y times the Z. So let's take a chance at getting this all done. Our density triangle gives us a very important little way of using some density and mass and volume and relating them all. Since we are accepting that the density of aluminum, we actually achieved this value in another lab, and we're all going to use 2.73 grams per cubic centimeter or milliliter, each would be fine. All we need to do is get the mass divided by the density, and that will be the volume as far as numerically speaking. So I go ahead and put my all my measurements and include the mass. So I have a measurement for X, went ahead and measured that, and that is 11. So your data can look like this, 11, and please use units, centimeters. Also Y, I got that, and that is 11.6 centimeters, and the mass in grams was 0.45 grams. Now this data is similar to probably yours. It is not the same. I had a different piece of aluminum foil, so your calculations may be different. So if I take all this information, I can take that mass and divide it by the density, and this will be my volume. So I'm going to go ahead and do this. I'm going to say 11, clear, 0.45 divided by 2.73. Okay, I'm going to try that one more time just to make sure I'm not messing up. Okay, 0.45 divided by 2.73, and my value is, the calculator says a lot of things here, but let me put them all down. 1,648,35 and some change. But since I have 2 sig figs divided by 3 sig figs, I can only put 2 sig figs down. And the 4 tells me to keep this as, I don't round up, in other words, 0.16, and this will be cubic centimeters. So this is my answer for my volume. And I know that the volume, like I just said above here, is x times y times z. And I know what x times y is. So I'm going to write this out. 0.16 will equal x, which is 11. And we're going to multiply it times 11.6. And then out here is going to be z. So let's go ahead and get those calculations. 11 times 11.6 equals 127.6. So this number is 127.6. Since I have 2 sig figs times 3 sig figs, I can only have 2 sig figs. So I have to stop here, and my answer was going to be 130. All right. Now, if I rewrite this equation just so we can see it maybe more clearly, it now looks like this: 0.16 equals 130 z, and I got to solve for z. So I'm going to divide both sides by 130. This is gone, and whatever our result here is will be our thickness. So 0.16 divided by 130, and this is 0.00, and it says 1230. So I'm only allowed to say 2 sig figs because of this. Both those numbers, 130 and 16, were 2 sig figs. So, and then I would need to, of course, put my units of measurement, which is centimeters. I hope this helps you guys. Be neat, take some pride in your work, and I would like this by the end of the bell.